All right, so this is day 3, me prepping for my software machine learning interview. I will try to bang out, hopefully, I can do like 2 or 3 questions before my daughter wakes up. It's about 8:15 now, so she might wake up. She might make up any moment now, but hopefully, she gives me about an hour, good hour, 15, 30 minutes, and we'll bang out some questions before we gotta really start the day and get her ready. So, mm, clean my glasses off. Share my screen. So I actually was working on this, and I want to do it without looking at it. I actually want to do both of these before I kind of start again. But let me get the question I want to do ready. So we want to do maps consecutive ones. Find the k closest element, longest substring with a most k distinct character, and then maximum size substring equals to k. So you kind of want to do these in like order. But I want to start with the find kth element first. So uh, here, um, oh, so I guess I don't have the YouTube video. I'll find the video then. Link address. YouTube. Uh, YouTube. Okay. So let's do class solution. And it says given an array of integers, so find first and last position. I forget what the actual function name is. So I'm just going to put first, last, last. I'm given an array of integers. So we define array of integers, say nums, list of integers, a list of integers, and then we'll have a target. Find the starting and ending position of a given target value. So we have a target, which is just an integer, and then we want to return a list of integers. So we will return a list of integers. And then given an array of integers sorted in a non-descending order, find the starting and ending position of a given target. If the target is not found, okay, so we can define a function called binary search, which will take in our nums, target, and a left bias. We're going to start by setting our pointers to 0, and then the length of nums -1. We want to set our index to -1. And now we want to iterate through nums. So for or no, no. So for Okay, I kind of forgot what I was supposed to do, and that's because I don't understand the question fully. So, given an array of integers sorted in a non-descendant order, find the starting and ending positions of a given target value. So, I'm going to get myself to 826. So, we set our left and right pointers, and then we set our index. And I know we need to iterate through target. So we need to loop through our target. So we'll say while left is less than or equal to right, then we need to set our midpoint. So we'll say mid equals left plus right divided by 2. And then we'll say if nums of m is greater than the target, right equals mid minus 1. Elif nums of m is less than the target, left equals m minus 1, else I equals m. And then we say if left bias r equals m minus 1, and then else left equals m plus 1, and then we just want to return I. And so we need to then do left equals r, left equals right equals, and then we're going to return a list of integers, left and right, and we want to say binary search. Takes in our nums, target, and then true, which is our bias. And we're just going to copy this, put it right here, and then change this to false. Yeah, run this. So, it's search range. I think this is right. Well, I know this is right. It took me a minute to remember, but I know this is right. Whatever, I know it's right. But that's good. I did remember at least how to solve the question. And then I don't even have all the question, but I just remember. Okay, so we're gonna have class solution. We're gonna define a function called vertical order, which is taking itself. It's going to take in a root, which is just an optional tree node. I think that's how it was. And then we just want to, and then you're going to return the vertical order traversal of its nodes values from. So now we just want to return root, and we want to return a list of a list, a list of integers. And so it says, given the root of a binary tree, return the vertical order traversal of its nodes from the top to bottom column. Our column of two nodes are in the same rows and columns. The order should be left and right. And so I know we're going to put this in a queue immediately. And so what we would do is say if, or we can say results equal, or we can just say if not root, return an empty array, or we could just say res equals return res, and then we want to say q equals collections dot dq. Now we want to add our root, so we say q dot append dot q dot append root, and then we want to say while q. Now since we want to another empty array called same level, and we want to say while q same level, while q same level. So let me read this. So given the root of a binary tree, return the vertical order traversal of its nodes values from top to bottom. So 9 through 5. We have and then and so 15, 27. Those are training range for I in length I just said length of q while q. So okay, let's go back. So we handled this first case. If not root, return if not root, return res collections q equals collection.dq, and then we're going to append our root. While q, we want to iterate through our q now, same level, and now we want to start traversing through our q. So for I and the length of q, I don't remember. Let me see if going back can help me. I think I already submitted the question. Is there a way you can already see your submission? I just look at a solution. Ready for the search. PS or above inside the work information that this whole since there won't be any broken points in the binary tree algorithm. To make this optimization, it suffices to make some small modifications for previous binary search approach during the BFS traversal. We can obtain a range of column indices with the variable min and max columns. At the end of the traversal, we will then walk through the column range min and max and retrieve the results accordingly. Okay, yeah. If root is none, if root is none, if root is none, then return empty. Okay, constant min max 0 q while q no pop left. If node is not none. Okay. So this is gonna be breath search. I'm gonna come back to this problem. This is definitely gonna be a problem that I'm gonna start on for the for search and DFS section. But I'm just going to stick on arrays for now. And then I'll go into graphs and trees. Let's start right here. Listen to the video. Y'all probably can't hear the video, but it's fine. left equal left right equals 0, and the length of array minus 1 minus k minus k. So on the left is less than right. We are searching for a window instead of just a val. And that we went through when our pointers are not equal to each other. Mid equals, mid equals left left plus right divided by 2. And so now we have to for array no yeah if if array m is greater than if it's greater than if, the, if our midpoint is greater than, it wouldn't be, I'm thinking array, right? I'm not sure. Let's see. If x minus array m Okay. So actually, even though the problem itself, like this problem seems is actually he says it's difficult, and which it actually is to understand. So I'm going to have to keep going through the problem again and again, or the video to understand just the intuition behind it, and even read some solutions. But problems like this help me code and understand the problem on a deeper level because it's really human readable, and this is really the steps that you do the whole time. So I feel like I can just solve this right now without having to look at anything else. So we're gonna struggle a little bit, but I think we'll be okay. So let's just do this, and I'm putting my hand over it because I just want to see what the solution is. I'm not even, or not the solution, but the function name is. So find closest elements. Class solution. We're going to define a function called find closest elements. I think is how it's spelled. I'm taking self. We're going to have a sorted integer array into integers. So we have on list. That's a list of integers, and then we'll have k, which is an integer. We have two integers k, so k, k, and then t or x integer. And then we want to return a list of integers. And then similar with all the left pointer and midpoint questions. So we start by saying left, right equals 0. We initiate our left and right pointer, and then the length of the array minus k, because instead of looking for a value, we're looking for a window. And so we'll say while left is less than right, array x minus I'm big tripping. And so mid equals 1 left plus right divided by 2. If array is it less than or greater than? Let's go array m minus m. Then was it minus x? I don't remember. Let's see. Let's go back to the solution. And then m plus k if x minus array m is greater than. All right. Class solution. Actually, I'm gonna just do it like this. Okay. Find closest elements. Define closest elements. Self array just do the list of integers. We're taking k as the integer, taking the x integer. And then we return the list of integers. And then we'll set our left and right pointer. The same as always, 0, and then the length of nums -1. And now we want to loop, or we say while our left pointer doesn't equal our right pointer, our midpoint equals left plus right divided by 2. And then if x is less than array m, if x1 is greater than array m plus k minus x, left equals m plus 1, else right equals m minus 1, and then we return, are we returning x? Let me see. Do we return x? Or return a? So return the array. Array 1 okay. So we set our left and right pointers 0, length and num. So while the left pointer is less than, or while the left pointer doesn't equal the right pointer, our midpoint is left plus right divided by 2. If x is less than the midpoint array, if x minus array is greater than minus x, then the left pointer is the, then we'll move the mid pointer to the right, else we'll move the right pointer to the left, and then then we return an array left pointer, left plus k. So I'm going to do this again. I might listen to the solution a little bit later, but for the second time, I'm going to keep going. So class solution define closest elements self. We're going to take an array, which is just a list of integers. We're going to have a k, just an integer. And we're going to have x, which is an integer. And then we want to return a list of integers. And so then we're gonna set our left and right pointer. Set left, all right, pointer, left, all right, equals 0. Length of the array -1. So we say while the left pointer doesn't equal the right pointer, the midpoint equals left plus right divided by 2. If x minus array m is greater than array m plus k minus 1 minus x, left mid left pointer mid plus 1, else left pointer equals mid minus 1, and then we return array plus k, and then we run a function while left right. Yes, images, k, integer, x, integer, and plus integers. I don't think I put that, that's why I didn't work. And so left, right equals 0, and then the length of the array minus 1. And then this will just be while left is less than right. The midpoint equals left plus right divided by 2. And then if x minus array m is greater than array m plus k minus x, left equals mid plus 1, else right equals mid minus 1, and then we return array left plus k. I'm forgetting something. Minus k, minus k. closest elements. Solution. Find closest element. Self array is a list of integers, and then we have our x or k integer, x integer, and then it's a list of integers, and then we want to set our left right equals 0, length of nums or array minus k, and then we're gonna say while left is less than right, if x minus array mid is greater than array n plus k minus x, left equals mid plus 1, else right equals n, and then return array l is k. I spell it wrong again. I meant to put this. So -1 also works here as well. Output, output, output. Okay. Complete. I want to do 3 questions. I end up most likely going to do 2 if my daughter doesn't wake up, which is still fine. And then I'll get back on a little bit later, and then we'll try to keep completing some more. The goal is to try to do probably like 8 to 10 today. Probably do 2 or 3 to 4 more, I'll say, array type of problems. And then I'll start getting into trees and graphs. Let's search. we're doing arrays, strings, sliding window, where is it? Prefix sum, 2 pointers. All right. And we want I just want to make sure that we're doing the appropriate things. Actually, this is what I'm going to do. I think in order, I read this post on LinkedIn yesterday, actually. And it was just talking about officially studying for the test instead of doing like hundreds of problems, specifically focusing on the problems, which I am doing. But I feel like I should pick and sort the questions and that have similar formats. Do those questions over and over again. So have some for 2 pointers, have 3 for 2 pointers, have 3 for prefix sum, have 3 for sliding windows, have 3 for binary search. Within these top, I would say people were doing like within the last 30 days. Um, so I'm going to focus on like the ones in the last 30 days. Or I just put the last like 3 months. I think 3 months is. I'll do the last 6 months. Yeah, I'm going to have to just dig deeper, and yeah, until I start understanding the patterns. So I'm going to keep doing what I'm doing now. I'm not going to change anything. Keep doing what I'm doing now. I think going over the problem like I'm going over is allowing me to start realizing the patterns, especially when it comes to 2 pointers and sliding windows. And then, of course, if I see something that's sorted and it has to do with array, most likely the optimal solution is going to be a binary search. So already just doing it, I can tell those few things or identify those few things. Um, you just want to make sure what you're studying is actually going to be helpful and prepare you the most for the actual interview. So just thinking about everything. I did this one question. How much time is it now? It's about 52 minutes we've been in. So we've been in for about 58 minutes. We did one question. We started another question. that's not good. We need to speed things up. We need to be more efficient with our time, and we want to see as many questions as possible because that's going to again just start allowing us to see the patterns more quickly. And so I'm actually going to take a break. Um, Probably going to take out some trash, do some other things. And my wife just said our daughter is up. So yeah, I didn't even know she said that, but makes sense. Something in me told me it was about time to stop for now. We're gonna stop for now, and I'll be back on a little bit later.